Okay, number 11, for the following function, find the domain. So let's start with that domain. Since we have a radical here, the domain, we have to make sure whatever's under the radical isn't negative. The square root of a negative number is undefined. So if x minus 3 cannot be negative, that means it has to be greater than or equal to 0. Add the 3 to both sides, x greater than or equal to 3. So our domain is 3 to infinity. We do not have to worry about this negative sign and this minus 4 because those don't affect whether or not things are defined. Okay, that doesn't affect our domain. It doesn't give any more restrictions. So that was the domain, sketch the graph using transformations. So let's talk about the transformations. We have three things happening here. This minus 3 is in the radical, so that is a horizontal transformation. That's going to be specifically a shift to the right by 3. This negative sign is out front. It's not under the radical, so it is a vertical transformation. So that is a vertical reflection or a reflect over the x-axis. And then this minus 4, again, not in the radical, so that's a vertical change again. That one's going to be a shift down by 4. So the square root function, the parent function, looks like this. It starts at 0, 0, and then it's kind of like a little parabola on its side here. That's the parent function. So if we're going to take that and shift that to the right by 3, 1, 2, 3, reflect. So that would, once I shift it to the right by 3 and reflect, it's going to look, hold on, let me draw that a little better. Just kind of trying to dash it in because this is not our final answer. It's going to look something like this. And then if we shift that down by 4, 1, 2, 3, 4 here would be our final graph. Shifted and reflected. Now on a test, these problems ask you to make sure you plot 3 key points. So what that means is you can't just come down here and plot that endpoint and then be like, oh, it looks like this. Okay, we need something a little more specific than that. We do need 3 key points. If you have trouble finding those 3 key points from your transformation, remember you can always help yourself out with a t-table for some of the values. Okay, if we transform and find this endpoint is right here, but we don't know where our other points are, we could plug in x equals 4 and x equals 5, 6, 7. Try some values, whatever works for you to find 3 key points to plot. Okay, next up, graph our piecewise function. Remember, a piecewise function is defined by multiple equations, and there is an x or a domain restriction on each of those equations. So if you have 2 equations, I want to see 2 t-tables to see how we're going to graph that. Okay, so this is going to be the t-table for x cubed, sorry, not x cubed, x squared plus 3. That's a parabola that has been shifted up by 3. X values have to be less than or equal to 0. So let's see what that looks like. 0 squared plus 3 is 3. Negative 1 squared is 1 plus 3 is 4. Negative 2 squared is 4 plus another 3 is 7. So let's go ahead and graph that. Notice less than or equal means 0 is going to be included in this part of my graph. So it is a closed circle. So 0, 3, negative 1, 4, and 2, 7. Okay, we do have an endpoint on one side because of the piecewise function, and it keeps going to the right. And then we need another t-table for 3x minus 1. And this is for x greater than 0. Now, even though it's strictly greater than, we do include 0 here because we need to have an open circle at that endpoint to show what happens as the graph goes all the way up to 0, even though it isn't included there. So if we plug in 0 to 3x minus 1, we get negative 1. We plug in 1, we get 3 minus 1, which is 2. Plug in 2, we get 6 minus 1, which is 5. 0, negative 1, open circle, 1, 2, and 2, 5. again, an endpoint at one end and keeps going to the other direction. That one, you should think about what shape you're going to see in each of these. This first one was a parabola, so it's a piece of the parabola. The second one is a linear equation. Mine looks a little wiggly, but pretend it's a straight line. So it's going to be a piece of your straight line. Number 13, we're going to do all kinds of things to these functions. First off, we're going to add them up. F plus g of x. To add two radical functions, I was right the first time. It's been a long week. To add two fractions, we need to have a common denominator. So that first fraction, we need to bring in the x plus 4. Can't just add the tops and the bottoms. Don't do it. It's not allowed. And then that second fraction, we need to bring in the x minus 2. And when we bring that in, we multiply it in, and we have to do it to the top and the bottom. Otherwise, we've changed our fraction entirely, and that's not allowed. Once we have that common denominator, we're going to put these together as a single fraction with that common denominator. And we're just going to add our way across the top. I'll go ahead and distribute here as we add. So I get an x squared plus 4x. Positive 3x gets distributed. So that's plus 3x squared minus 6x. We should look for any like terms that can be combined. We do have some x squareds. X squared and 3x squared gives us 4x squared. Watch your signs here. 4x minus 6x is minus 2x. And that is all over x plus 4, x minus 2. We'll talk about domain in a minute. We're going to do all the operations first. F minus g looks just the same, except we're going to be distributing a negative 3x when we get to that step, because we are subtracting now this time. Be careful with that sign. So same idea, we're going to multiply in. I'm going to skip a step here since we did it above. We're going to multiply in the x plus 4 minus 3x and multiply in the x minus 2, and the whole thing is over x minus 2, x plus 4. Again, I brought these in so I have that common denominator. It looks just like when we add them, except now, like I said, we're distributing that negative 3x. So when we distribute, starts off the same as the first one, x squared plus 4x. But then we have minus 3x squared, and be careful, here's where everybody makes the mistake. Negative 3x times negative 2 is plus 6x. Again, combine your like terms. Again, watch your signs. X squared minus 3x squared is negative 2x squared. 4x plus 6x is plus 10x. Oh, I made a mistake when I wrote down the answer on the last one. Did you catch it? If you caught it, good job. That should not be 4x to the fourth. You don't add those exponents. They are like terms. The exponent stays. It's x squared plus 3x squared, which is 4x squared. Sorry about that. Okay, on to the product. We are going to multiply these two functions together. Multiplying functions is actually easier than adding and subtracting because you do just multiply straight across the top and straight across the bottom. Straight, straight. So up top, x times 3x is 3x squared. On the bottom, I would even just leave it factored. We usually like things to be factored anyway, so I wouldn't even bother foiling that out. I like that answer, just like that. Nice and easy. And then we need to do the division. Need to give myself a little more room for that, maybe. Scroll down. Oh, we're going to run out of room, aren't we? F divided by G. When we divide fractions, so we have x over x minus 2 divided by 3x over x plus 4. Division of fractions is multiplying by the reciprocal of the denominator. So we write down the first fraction, then we change it from division to multiplication, and we flip over that second fraction. I don't want to distribute right away because watch what's going to happen. I'm just going to write it as a product on top. Again, multiplying straight across the top and straight across the bottom. See why I didn't distribute? Because now I can see real easily that they have a common factor of x that we can reduce and cancel those x's. So our final answer would be x plus 4 over 3, x minus 2. Okay, now domain. We need to talk about domain. So the domain for the sum and the difference and the product, they all have the same domain, and they all are based on the domain of the original two functions. So we need to look at the domain of f of x. Remember, f of x was x over x minus 2. Domain on a function like this, what we're watching out for, division by 0 is undefined. We want this fraction to be defined. So all numbers are going to be okay, except the number that makes the denominator 0. In this case, we don't want that to be 0, so that means we don't want x to be 2. So the domain of f of x is all real numbers except for 2. Then we also have to look at the domain of g of x. G of x was 3x over x plus 4. Same rule. Again, we have a fraction, so we don't want the bottom of the fraction to be 0 because division by 0 is undefined. So x cannot be negative 4. So the domain of g of x is all real numbers except negative 4. The overall domain of the sum, the difference, and the product, we intersect these two domains or put them together. So our final answer would be all real numbers except, and we have to kick out negative 4, and we have to kick out 2. There is our domain of the sum, difference, and product. The domain of the quotient, we are going to take these two things into consideration. These are important for the quotient also, but there's one more thing. Because it is a quotient, because we are dividing, we have to make sure, again, we're not dividing by 0. So since it's f of x over g of x, we have to make sure that g of x is not equal to 0. So 3x over x plus 4 cannot be 0. The only way for a fraction to be 0 is if the top is 0. So that means that 3x cannot be 0, and that means that x cannot be 0. So for the quotient, we have the same restrictions that we had on the first two domains. Can't be negative 4 because of g of x, can't be 2 because of f of x, and then x also cannot be 0 because that would make g of x equal to 0, and we can't divide by 0. So that's the domain of the quotient. Okay, next up, number 14, we're looking at some composites here. We want to find FOG of x, which the definition of that is whatever function comes first, that goes on the outside. Whatever function comes second, that one goes on the inside. So this is what we're trying to figure out. What I like to do first is replace, this is the label. This tells us what function to use. Here is the actual function of g of x. So that's what I'm going to do first, replace that out. Okay, that took care of g. Now I'm going to look at f. F says take 3 times x. I'm going to put something in place of x over x plus 7. So what I need to do here is plug in whatever was in the parentheses. It has to go in both places that we had a variable. Okay, so that's it. We do need to simplify because right now it's a complex fraction. So we're going to simplify this by multiplying the top and the bottom by 2x. You can think of that as 2x over 1 if that helps you line it up with your fractions, but we do that because the 2x cancels here, and what we're left with on the top is 3 times x plus 1. On the bottom, we have to distribute that 2x, so it is going to cancel in the first fraction. In the second fraction, we need to multiply it through. So we have the x plus 1 after the denominator cancels, and then 7 times 2x, because it didn't cancel here because there was no fraction. Distribute up top, and just multiply on the bottom. And then combine like terms. There we are, 3x plus 3 on the top and 15x plus 1 on the bottom. It asks us to also find the composite in the opposite direction. So we flip everything around. Now we want to find g of f of x. So this time g is first, it goes on the outside. F is second, that goes on the inside. Okay, start off by replacing this label, f of x, with the function itself. For our problem, f of x is 3x over x plus 7. And then we're ready to look at the definition of g of x. G of x is something plus 1 over 2 times that same something. And what we plug in there, what goes in that place of the variables, whatever we had in the parentheses. It's f of x this time. Okay, we've done all our composite. Again, we ended up with a complex fraction. We need to cancel out those little mini fractions. We don't want them in there, so we're going to multiply top and bottom by x plus 7. Up top, we do need to distribute that. In the first term here, it cancels, and we are left with just 3x. In the second term, it does not cancel because there's no fraction to cancel it with, so we just multiply 1 times x plus 7. In the bottom, it cancels, and we get 2 times 3x. Go ahead and do that simplifying. Up top, we have 3x, distributing a 1. I could have just left that off. And on the bottom, 6x. So our final answer, 4x plus 7 over 6x. You can't cancel those x's because we would need to cancel into both terms above. We can't just cancel into the first term. That 6x applies to both the 4x and the 7. So we don't end up getting to do any canceling there. And number 15, again, composite functions, same, very similar process. They just used a little bit different notation for us here. They went straight to the f of g of x notation rather than showing us that little circle step. So same process, replace g of x, the label, with the function itself. Then we want to look to the function f. F is 6 times something squared minus 5. What goes in that parentheses is whatever I had in the parentheses here. Okay, we do want to go ahead and simplify this out. Be careful. We want to do the exponent first before we distribute that 6. Exponents come before multiplication. So 4x plus 7 squared, we have to FOIL that. You can't just square each term. That would be 16x squared. We get a 28x and another 28x, which when we add those together, that is 56x. And then we get a 49 plus the minus 5 that we had hanging at the end. Distribute your 6 through there, so we get 96x squared plus 336x plus 294 minus 5. And then finally, we just want to combine those two constants, those two like terms at the end. And there is our final composite answer for the first one. Then again, we'll flip it around and we'll do g of f of x. Replace f of x with its function definition for this one. That is 6x squared minus 5. Then we look to the function g, which is 4 times something plus 7. I'm looking at this, 4x. That's where the input goes, where the x is. And our input this time is 6x squared minus 5. We'll distribute that 4. We get 24x squared minus 20 plus 7. Combine those two like terms, and we get 24x squared minus 13.